Hello, everyone. Thank you for coming. I will give this presentation in English. I've been asked to do it in English, so which is kind of like funny because I'm in Poland and I've been asked to speak in English. And last week I went to barber shop and they actually asked me to speak in Polish. So I don't know, a bit confused about it. Maybe Polish become a lingua franca. So yeah. Again, welcome everyone. Are we ready for the presentation? Yeah. So I will present today about SSL TLS for mortars, which is a security talk, and I will try to explain SSL TLS, why it's important with the simple terms without using too much jargon. Basically, I'm not the security specialist. I leave these all jargons. For them, I would try to do as a human to human, rather than just to look smart. My name is Marcin. I live in London, but I'm Polish. Yeah, and again, welcome everyone. Just don't be shy. There is a lot of space, looks like. So let's start. Few words about myself. My name is Marcin. I'm a software engineer at Icon Solution, which is fintech in London. And I'm not a security expert, as I mentioned already. So maybe in some cases, if there are there any security experts on here. So maybe sometimes I will say something wrong, so I apologize. But again, this is what I know, how I understand the stuff, and I just want to share it with people. I'm also Jakarta E steering committee member. How many of you know about Jakarta E? Oh, quite a lot. Are you using it in your day-to-day work? I would say probably every Java developer uses it, but not everyone knows. At least some parts of it use it, which is very important technology, but probably is very good because people just use it and don't even think about it. Yes. I'm also a sparring speaker. That means I'm not a pro. This is my second conference talk, so I apologize if I do something wrong. And I'm also community builder. Until currently, I was probably the most active person in London Java community. But that changed, and 2 months ago, we opened with a group of other people another JAC, which is a JAC for everyone, where we organize regular events for the community in London. If you will be in London anytime soon or wherever in the future, you wanna talk or just join us to our events because we organize them regularly, please join us. You can speak about it with me as well. Okay, something's wrong with the presentation. Yeah, so that's the logo of our new community, but it's not important what me is not the most important person here. Yes, and who knows that Java 25 has been released this week? Some not, or they are shy because probably you missed this conference a lot because there was a lot of talk about Java 25. And in this release, there are two important things for kind of like from perspective of this talk. The first one is JEP is 470, which is kind of like what I will talk about, but more from email perspective. It is the same kind of like the concept using cryptography and secure certificates, but on the email level. And the second one probably is even more important from perspective of the what is called. Okay, in the future, like the cryptographic say that will be because of this new computation model will be obsolete, and that's actually address that, which is these new computers. Okay. Quantum computing, yes. So basically, this is kind of like address concerns about the cryptography in the quantum computing. Okay, so behind every good talk, I hope this one will be one, is a story. So how I came to the idea of this talk, yes? So I came when the Russia attacked Ukraine. There was the topic on Reddit that Russia creates its TSL certificate authority to bypass sanctions. So basically when Russia attacked Ukraine, the Western world put the sanctions on Russia, and one of those was they revoked the access to the certificate authorities in the West. So that means the website couldn't attain new certificates, yes? And the thread has a lot of like the talks which basically I think they are not true. So one of them was like the myths, yes? Russian government tracks by the citizens, or this move will help them to do it, yes? CIA and NSA will hack Russian websites. Site without it will be inaccessible. So many things are wrong in this statement because Russia spies, or the same Americans, they spy on their citizens without this, and this technology has nothing to do with it. And yeah, there is a problem with in accessibility, but you can still, even if you don't have like active or expired certificate, you can still access that website. It's just some warning now in web browser. So I decided first to argue with internet, trying to explain then, and then I said, why not talk to wider community about it, yes? And another reason is because I believe SSL TLS is one of the backbones of today's worldwide web, which is basically internet, and without it we couldn't do the things we are doing today. But it is complicated, yes. I don't know about you, but first time when I have to generate my own certificate to do something with Java, I'm Java developer, I tried to find resources, and the easiest I could find was this Stack Overflow question answer, where this is the simplest one, but when you look at it, it still looks very complicated, yes? There is a lot of some words which I have no idea what they mean. So basically for me it's like a magic which I just copy paste into my terminal, and I hope it will behave. But often we finish like it's just chaos, and we end up with something like this, which we don't really understand what that means. Yes, it's just stack trace of related to certificates. Yes, something went wrong. So we hope to have in our team someone like Gandalf, who will tell us, hey, what happened wrong, yes? So I hope at the end of this talk we will be probably a bit closer to the Gandalf than we are now. So a bit about history. Maybe another question to you: who was born before 2000? Oh, so you remember the times when the HTTP, when all of the websites were static. So basically what that means, there was some content served by the server. We just see it, we couldn't really interact with it. And HTTP for that was good enough. Okay, someone could alter the message, yes. But it didn't have too much implication. Okay, maybe there was like fake news or something, but really didn't affect us on other many ways. But with the born of Web 2.0, which is around 2000, we completely changed the way we interact with webs, yes? Social media, banking, services, everything. You said a lot, so now it's communication both ways, yes? And we want to make sure that, one, the other side we talk with is actually the one we think they are. We want to make sure that the message we send or they send to us is actually the message they sent, no one changed it. And third, it is safe, yes? Probably no one can see the message, yes? Because we probably send some passwords, some data which is, we don't want anyone intercept that, yes? So that's why this guy here is like black hat hacker who try to intercept our traffic, yes? So we want to avoid that, and this technology, HTTPS, TSL, TLS, allow us to do it. And also there is another problem when there is, in normal world, when we go, I don't know, to the bank, we trust that this is the bank we actually going, yes? In connected world, in internet, we don't really know, so there is like limited trust between two parties. So we really want to make sure that we speak someone who we don't see, physically don't see on the other side, who is who they pretend to be. So yeah, we had to come with something better than HTTP, which was HTTPS, which is a secure extension of HTTP. And it used TLS protocol to provide encryption, and by extension, integrity of message, authentication of parties, in communication between the client, mostly the client, web browser, or our service, and the server or another service when they want to, exchange some information. So yeah, so another one, TLS states for transport layer security, and why we actually have SSL, TLS. SSL, there are two, they are not different. Basically SSL is old, and at some point SSL has been developed by Netscape, and then when become kind of like the standard to differentiate between SSL, which was owned by Netscape, they come with new name, TLS, but it just stick that we use it together, and basically people just use it together, but basically it's the same thing. SSL is old, no one should use anymore SSL. TLS is the new, and you really should use TLS, yes. And the newest version, which we'll talk about more later. And yes, how it works. So basically, when we send the first request from everybody, probably is familiarized with the handshake, TCP handshake, yes, which there's a lot of memes about it. This is kind of like similar. So before the two parties establish the connection, they have to kind of agree on the protocol they want to use, what they want to use, how to use. Are you actually the person I'm talking to or service I'm talking to? So basically to establish that channel, initially the algorithm to establish it protocol use asynchronous encryption, and then when the handshake, at the end of the handshake, they establish synchronous encryption. What's the difference? Asynchronous is that there is a pair of keys. When one is public, another is private. So you have to, for example, when only person with the private key can read the message which was encrypted with its public key, yes? And kind of like opposite, when you encrypt something in the private, it can be only decrypted with the public. When it moves to synchronous, there is only one key, which actually, but I will talk about it. Let's see if people spot the mistake on my slide. So there is only one key, and there is less overhead to decrypt that. That's why when the parties are, the channel is set, they move to the synchronous encryption. And how it works, basically. So this is the kind of like sequence diagram explaining the handshake. It's simplified. It depends on the algorithm, which we talk also about a bit. It depends on the algorithm used by the protocol. But there are three kind of like distinguished sections. in this diagram is initially is actually asynchronous part, then is optional part, and then is moved to synchronous, and we will discuss a bit of what's happening here. So as I say, initial handshake is done with asymmetric encryption, which basically looks like we send, okay, let's from we. So from perspective of the like web browser user and connecting to the server, yes. Web browser initiate the communication, yes, sending the request saying, hey, I want to communicate with you. And this request, and again, it depends of the algorithm, yes. But for the purpose of the talks, let's say it sends the request with pure HTTP, can be sent, and this request request from the server that the server sent is public key back, and also the algorithm to be used in the setting up the communication channel. So that means why is this important? Because it's now, I think it's TLS 1.3. And why we need newer version? Because there are some holes found and they've become less secure, yes. And there was, I think, a few years ago that there was like big hole found in TLS. That's why they moved. I think 1.3 is now, they advise to use it just because the previous versions are not safe. And this also means that it's important to patch your servers and clients, like, I don't know, Firefox. I found some time ago that my Firefox was not updated like for 2 years. That was not really safe, yes, because so then the client and the server, they negotiate the most secure algorithm to start the communication, yes. So when you have the newest web browser and the server, then they will agree, okay, the newest algorithm. So again, it's very important to keep your software up to date, yes. So when the public key is sent, it's also sent with the certificate, which is authentication certificate, CA, which tells the client, hey, I'm speaking with this, actually, who I want to speak. Like, for example, you connect with your bank, the certificate say, authenticate that this is my bank, not some other website which pretends to be a bank. It is basically what we try to connect from to. And then there is optional step, which basically our client will connect to the certificate authority, which actually granted that certificate to actually check if the certificate was not revoked, is it still valid, and it's actually true, yes. But why this step is optional? Because it depends on the settings of your web browser. If you've done this step, or your web browser done it, this step, let's say 1 hour ago, there is no point to do it again, especially, if it's not, I think it's based on the settings of your web browser, but I think that the default is about a month. If you've done it in the last month, then it's not done again. But if we also talk a bit more about this step in the next slides. So yes, we verify that actually the party we want to talk is the right one. And in the next step, our client web browser, we generate the symmetric key for the session and encrypt that key with the server public key which has been sent before, and send it back to the server. So that means only server can read that key. So there is no risk that someone will read instead that key. So we kind of like making sure that no one else will be able to when we move to the synchronous communication, no one else will be able to read that our messages, yes? So then what happened on the server side? On the server, the synchronous key is decrypted with server's private key. So then the secure session channel, it's called different names, is established, and yeah, there is a move to synchronous communication. And there is obviously, as I mentioned before, there is a bit of mistake on this slide because I said here pair of symmetric keys, yes, which is incorrect. It should be only one key, which you can read and encrypt and decrypt messages. So yes, let's talk now a bit more about the certificate authority. And by the way, if there are any questions, just stop me. I think we have a lot of time, so there is no problem. If we talk about it, you want to, I say not true, so we can discuss, or you have additional questions, so feel free to do it. So what is certificate authority? Yes, it's basically in the real world, a lot of is based on the trust. We trust our friend when we say something that they don't say something, yes? That's how trust works, yes? But we also build like the chain of trust, which means that, I don't know, I trust my wife, and by kind of like inheritance, I trust also her friend, yes? Kind of, I don't know if that's good, but because we trust someone, we trust also the person they trust. So we build the chain of trust. We don't necessarily know the next person, but because someone we trust know that person, we trust also that we can speak with that person, yes? So that's how the certificate authorities work. So at the top of the trust chain is root certificate authentication authority, where is like the big organization which then creates certificates for the other organizations, which then creates certificates for example, for web servers, yes? So you see, you have to trust the root CA, to trust this immediate CA, to trust that the web server certificate is actually valid, yes? But we don't know root certificates, yes? There might be some company in States, and we don't really trust them, yes? Because we don't know them, yes? So someone has to be at the top of that even higher in the trust chain, which is basically, in our case, when we talk about web browsers, a web browser vendor. So for example, Mozilla for Firefox, I don't know, Google for Chrome. So they add the root certificate authorization organization today to web browser. You can check those certificates, go into the settings, and you will find that there are root certificates for many of those. And this is also important from point of our story, because when Russia create their own root certificate authority, the major vendors didn't add it. So still, you could see on the website that the certificate is not really valid. Yes, okay, you could see the website, but there was a warning that, hey, we don't trust this certificate because the web browser doesn't trust this root certification authority. And I also added who knows about Let's Encrypt? Yeah, quite few people. So in the past, the process of attaining certificates was very like manual. You have to copy the certificate from somewhere, then put it on your web server, and this was bug prone and quite difficult. let's encrypt, make it much easier and automated process. And by this, they change it to be like in past, we were changing certificates once a year, once to 2 years. And let us encrypt say that we should change certificates every month. It's automated, it's very cheap. So why not make it even more secure? And the problem again was this Russian. I think they give the certificates once, 5 years, for 5 years. So there is another problem with this because you can break the key which certificate has been created with. We just talk about this computing. Yeah, quantum computing. Soon might change. I understand, like, one of the person is yeah, I know it's difficult, but it's not impossible, yes? So the changing your certificate is one of the security options to make it even more secure, yes? Yeah, and then, so let's script create certificate for your website. You put it there, and then you, what's happening? Yes, so then you can see in your web browser this icon, locker, which is closed. That means it's safe, but there is more about the certificates. So there are different validations levels. So domain validation, so basically most websites, use this one. So this means that the owner of the service have to only prove that they own the website, the address. So basically, this is mostly done through the DNS record. You add the DNS record, and they try to connect it, validate. Okay, you control this record, so that means you own the website, which is very weak, but is in most cases is enough if you connect with, I don't know, blogs, some websites, private website. It is good enough, yes. It's the cheapest, but it's the least verified because it's kind of like automated, no human interactions in this process. But again, for some, it is enough, for others not. And again, it's here. It's example of that domain validation. I just went to some blog. Click on this locker, and there is like certificate details, or I don't really know what is the option, but you can see all details of the certificate, and there is certificate policies, and one of them is domain validation, the validation levels, yes, which in this case is domain validation. And then I went to bank, which is actually, you can see which means Barclays. And you see they have extended validation, which means that they went through the more rigorous process. Like actually the organization which provide the certificate, they have to contact, they send letter for the given address to make sure that actually the organization they give the certificate for is actually the one which they say they are. So every bank, big corporations, when the trust should be very strong, should go through this process. And the sad thing about, I checked that in Chrome, Chromium, and Firefox, they don't really distinguish like the first look at the, I don't know, web browser to say which one is this. I think, if they put, I don't know, maybe green color on the locker, that would mean, okay, is extended verification, validation. The yellow could be organization validation, and the domain should be still the same. But it's really, you have to dig deep to know which one is, that information for most of the users is just useless because I'm not going to the, this level of details to check if the communication is safe or not. I just trust this is good enough. So yeah, let's go back to debunk the myths. Yeah. So basically, first myth said that the Russian we spy on the citizens with by providing certificate root certificate authorization. Do you think it's true? Because the point is there is no intermediaries with except the root certificate authority or certificate authority when we check actually if we talk to the right person. The rest of the transmission doesn't go through any intermediaries. There is no again, I simplify here because I see again some smiles, but it's basically, the communication is between two parties. There is no they can, in the diagram I was drawing before, that there is this hacker, they can, but they cannot even read it because it's encrypted. They don't have key for that, yes? But there is another risk related to this, because it's not only certificate authority Russian government is controlling, yes? If they control the whole infrastructure for the internet, which is the case, and probably the totalitarian governments as well, then they have other means to do it, and they do it, and probably at the Western world we are the same. Maybe it's not us in the light spot, but yeah, I'm definitely believe that they do as well. So if, for example, if they control DNS servers, they can say, let's say, I don't know, like with my example, Barclays CO UK, they can say, this IP is to Barclays CO UK, yes, rather it's not the one in UK, it's one in Russia, yes, and they can provide actually the certificate, and so yeah, by controlling the whole infrastructure, they have more means. So it's risk, but it's really the risk. And the other point is, in the case of the communication itself, like one of the colleagues here was, when I say can be decrypted, encryption now is really good. It's not easy to actually break it. So there is, for us normal users, maybe there are some use cases. I don't know, someone is very important on the top of the government, I don't know, Elon Musk, whatever. They are important enough to someone want to invest the resources to break the communication. For us, most of the time, is we keep updated our software. Probably there are more risk related to I don't know, we go some dodgy websites. It's more risk to infect our computers with viruses, backdoors than just because of we using this technology, which again is kind of like bringing the point about the noise. People say a lot of words without understanding actually how the technology works, and this was kind of like, no, you are wrong. I try to explain how it works, and yeah. So again, as I mentioned on the slides, at the time, major web browsers vendors didn't recognize those certificates. So there was still, probably you've seen like self-signed certificates or expired. You can access this website, but you have the big warning. Do you really want to do it? So that's the case with this one, yes. And only local vendors like Yandex recognize it, which Yandex is Russian company, yes. So they do it. Yeah, and probably that's enough. That's all I have for today. It's a bit short. I have 60 minutes, but I don't think there was enough content to talk about it. So if you have any questions. Can be in Polish. I speak polski też, także nie ma problemu. So Yeah, there is.
Sorry. Maybe would you like to mention MTLS? How does it work, or is it too complex question?
I have no idea what is MTLS.
Oh, like when you have the TLS and you verify that the server is the one that you are trying to connect to, you also verify client from the server, that this is the client that is allowed to speak to you, like a double verification.
So probably it's one of the algorithms I was talking about, which, but seems
Okay.
like you know more than me
Okay, never
about
mind.
it. Yeah. So if you wanna talk,
No,
is
I
no,
just-
no. Sorry,
Okay,
I never heard about MTLS.
okay.
As I mentioned, I'm not the security expert. This is the knowledge I gain by just working with certificates. Be a bit curious, yes. So.
Cool. Another question just popped to my mind. Like you showed this sequence diagram, how TLS handshake looks like, and there was a step where you verified that CA, request identity verification. So is there any chance that man-in-the-middle attack can target this step, that they can try to impersonate the CA here at this step?
I think I've got this question again, and again, I'm not the expert, and we, through the discussion, say yes, but it's a really good question, actually, because I think there is a risk of this, because if maybe there is, like, okay, because I don't think so. Yes, okay. When I think about it, it's not, because the certificate, root certificate you install in your is provided with your web browser. It has public key of the certificate authority. So only the owner of the private key can read it. So, and the private key will be owned by the certificate authority.
Okay.
So I don't think so there is the risk, but again, probably, as probably we all know, there is all the fight between hackers and us, and they know better than us. Definitely, we are less informed than them about all the possibilities. Any more questions? Okay, then. Thank you for your time.